My name is Chris Saunders. I am a platform architect with Pivotal Federal. My role is to help customers get the most value out of Pivotal Cloud Foundry. And today, Jason and I, who will introduce himself in a second, are going to essentially cover some security features in Pivotal Container Service, but do some relation to the DoD in that space, because that's where we spend a lot of our time. Jason, you want to introduce yourself?
Yes, sir. So Jason Skanga, work for VMware. I'm based out of Colorado Springs, Colorado. I cover the NSX side of the house, so the Network and Security Business Unit, basically covering all of Department of Defense. And today, myself and Chris will kind of go over the PKS overview and how to secure our workloads.
So I wanted to start this conversation about the evolution of military tactics and thinking about mobility. So doing some research for this presentation, I found out that in World War II, one of the ways to get munitions, supplies, armaments into the soldiers, into the warfighter, was via horses. A way to get soldiers that were wounded out was via horses. Sometimes they couldn't get the big half-tracks and whatnot into those areas. And then a mere 15 to 20 years later, we had AirCav in Vietnam doing the same thing. So that was a big revolution in terms of technology, going from horse to helicopter and fighting the battle. Yet, if you look at the average cycle time, the time we have an idea or requirement and we get it into production in major weapon systems throughout DoD, typically takes 8 years on average. And that's from 1990 to 2015. So 8 years to get an idea into production. So in the battlefield space, we can innovate and create this great technology, but in IT, we're still stuck in 1990 and 2018. Seems kind of odd, right? In terms of military tactics, protection and security, we had castles at one point were the way to fortify battalions, and then people overcame castles, and because they're too tightly packed, we could use technology to defeat those castles. And we moved away from that to a very wide perimeter basis with lots of different barriers in between, compartments, segments, access points, different ways to verify who you are, different technologies to prevent the enemy from basically breaching those fortifications. But if you look at the way we build DoD networks today, it's similar to castles. You have a very hard perimeter and an incredibly soft middle. And that goes from classified, unclassified, wherever it is. The outside's very hard with firewalls, the inside's an egg. It's incredibly soft. There's east-west traffic flowing everywhere. So we haven't really evolved in terms of our networks and how we guard against intrusions and quite frankly, interior intrusions and breaches inside. Then we have the evolution of military tactics, mission command. If you're not familiar with this term, it all came out of Napoleon being able to defeat the Prussians in a very rapid fashion. He's able to do this because the Prussians would literally send orders out via horse-driven soldiers. They would take the orders out. The battle's already going on. By the time they got the next order, the battle had progressed very far. And the Prussians got beat soundly. And when they did a study of this, they realized that Napoleon was using autonomous orders. Essentially, I will give you the intent as the commander. You, as the lieutenant in the field, will carry out that to the best of your ability. But you have autonomy on how you carry that out. Yet, when we move to today, the idea of developing software is like sending someone out on a horse to tell the command, right? We have a presentation up. So if you walk through a typical dev cycle, we request the environment, we get some VMs, open the ticket, there's gates, there's controls, there's all these things. We don't trust the people that know the code intently and understand the dependencies to release that code. We still trust someone at command who may not understand what's going on in the battle of IT, but we still go that way, right? So there's challenges there. So how can we help DoD evolve IT, right? And I think some of you may have seen that earlier today with the Air Force. But for us, and for especially folks like me, It's to help you choose the right tool for the job, the right abstraction, right? Whether that's delivering that in a container or delivering that capability in an application platform or eventually serverless, right? Understand those use cases. Understand why you're putting that workload where. There's obviously room for all workloads like we talked about in some of the talks today. But working with folks like me to help understand that. And obviously the higher up you go at the stack, the more efficiencies you get and the less complexity. But sometimes there's reasons you stay lower in that stack. And just choose that right tool for that job. So with Cloud Foundry, we have some typical outcomes, right? And I think the Air Force talked a lot about speed and be able to rapidly deploy new capabilities of the warfighter on a continuous basis. And then there's stability and scalability. Stability in terms of our environments, they're very consistent. We don't have, hey, it worked great in my laptop, but it failed in production. We're going to provide that outcome. But today what we're really going to focus on, especially for the DoD, is security and have security baked in and automating security and how do we meet security controls. And that's some of the topics we're going to cover around the DoD. So what is Pivotal Container Service? It's really a day one, day two operational capability to manage Kubernetes, provisioning, patching, upgrading, all those things. Right? It's adding a lot of value to the operator of that Kubernetes installation so developers can build microservices, run COT solutions, turn some legacy workloads onto Kubernetes. Very important in managing it. However, out-of-the-box Kubernetes only gives us a few things we need to run Kubernetes well. From the developer side, they have the API, they have kubectl, they have a dashboard. But from IT ops, well, there's a lot of challenges there. There's not an easy button to deploy, manage, upgrade, monitor Kubernetes itself. There's logging, there's monitoring, there's a registry, there's all sorts of operational aspects that are not ready day one when you install Kubernetes. Even Kelsey Hightower, Google extraordinaire, Kubernetes is a platform for building platforms. It's a better place to start, not the end game. PKS is a great start. We're going to provide a lot of the capabilities that are missing to really get some extreme value out of Kubernetes. From day one, day two provisioning with the magic of Bosch, to integrations we have with VMware around NSX, Harbor, and some other tools they have to monitor and manage the environment. Today we're going to really focus on the NSX side of the house and how we secure those workloads, but also Harbor. So security and PKS, if we look at a pipeline that we see common for federal to meet ATO requirements, you'll see security shifting left. So instead of delivering applications at the end, having security come in and scan those, we're going to move a lot of those tooling up to the top, to the left. We're going to automate a lot of the controls they have to meet to get ATO, and we're going to make sure that code's safe and secure before we release it into production. And Harbor will take a big place in that. But when you hear this term, move security left, I think that's what most people are talking about. So let's understand, are there clear text passwords? Are there SQL injections? Are the stacks that I have vulnerabilities in them? How do I ensure those containers that I'm deploying don't have vulnerabilities and they are the ones that I actually deployed in my repo? These are the type of things we need to think about when securing workloads. It's building this DevSecOps pipeline. So, for patching, a new security patch is released for Kubernetes, and Pivotal will release the CVE for that. And this is sort of the value that Pivotal provides. We are managing those patches for Kubernetes and the CVEs. You as a customer, you don't have to provide that. You don't have to have an expert in how do I patch and manage the Kubernetes infrastructure itself. Pivotal provides that. So we can do that with zero platform downtime. So we can upgrade your Kubernetes clusters with no downtime to your users or to your developers. Or even better, and what security loves, is treating Kubernetes like a product. We often see customers do CI/CD pipelines for their developers and for their applications, for speed and for security. We also want our customers to do that for the platforms they support themselves. So having automated pipelines that update Kubernetes with potentially zero intervention from a human, or patch Kubernetes, or install Kubernetes, We have concourse pipelines that our customers can use to get to platform as a product. So you're automating the platform aspects. It's immutable. And the best part is Pivotal maintains these pipelines, and Pivotal maintains those patches and that Kubernetes level for you. Not something you have to figure out, script, etc. Harbor. Harbor is an inter-class registry server for Docker images. And what does this really mean? Well, you want to have the ability to make sure you don't have vulnerabilities in the Docker images that you put in the repo. So there's a scanning aspect to this to understand what those vulnerabilities are. And then it has an API, so you can integrate that into your DevSecOps pipeline. Also has a signing capability, so you can digitally sign that image. So before you release anything into production, you pass all your security controls, and then you sign that image, and then we deploy it in production as part of that pipeline. We also have replication capabilities between sites, so for availability. Availability is very key to security. We also have auditing, so who did what to the repo, who added what, who pulled what. So very important when you have security audits to have that capability. And this is part of PKS. And now I'll turn it over to Jason.
Thank you, sir. So Mr. Saunders did an outstanding job of looking at what PKS, what it is as a package, how the PKS API talks to everything. But let's talk about how we can actually secure this package. And with that, we can actually go into what NSX can do with PKS. Okay, so think of it as this way. Now I'm actually having a container network aspect. I'm able to do microsegmentation, which is security policies automated for you. One of the biggest things I like to point out is we have now, enterprise support that you get versus having an open source networking tool. And that's something really you want to think about when you start doing open source networking, with VMware and Pivotal being a partner, we actually have that enterprise support for you, and especially at that GSS federal level, you are able to get that. Of course, load balancing, routing, switching, and most importantly, how we do multi-tenancy inside the environment is unique to how we use NSXT and actual PKS together. So let's talk about multi-tenancy for a minute. So when we look at multi-tenancy, and Chris just explained basically what PKS is and the control plane, which is the PKS API call, to Harbor and other platforms as well. Underneath, with the actual structure using Bosch, we then leverage NSX. And NSX gives you that foundation to actually automate security and actually do multi-tenancy on your classification networks as well as your unclassed networks as well. So it's just imagine like now that I can actually deploy these container solutions and have multi-tenancy when I deploy them. So whether you're doing, with Kubernetes cluster, you get the master, you get the worker cluster, and I can create my namespaces, which I'll show you in a demo in a minute. But with that multi-cluster now secured and the single cluster now secured, I'm able to automate this infrastructure as well as give those applications security at its finest. So what PKS can do, and if you look at the broad spectrum of VMware and Pivotal together, we give you the foundation, which is the infrastructure level with vSphere. And then obviously we get then the next step, NSX, which is embedded inside of the hypervisor and gives you that security at the common core level for the virtual machine. And then using PKS, I can now deploy my Kubernetes workloads with my master and my different clusters of workers to give you that endpoint solution for security. And then also an operarization aspect, so I can basically use operation tools to look into those containers as well as understand the health and risk efficiency of those working container solutions. All right, so Kubernetes topology, okay? We create namespaces for you. We give you the pods and nodes aspect. I talked to you about security firewalls using microsegmentation. We automate that for you. And I'll show you in a slide here in a minute how that looks. We not only do like the northwest traffic security, we do the east to west, which is ideal because if you look at a lot of your workloads today are being protected east to west traffic. So now we give you that microsegmentation to secure those workloads. Visibility and troubleshooting, I say again, is the operational tool set that is missing today in a lot of the application workloads today, whether you're doing multi-site or you're going into the public cloud or you're doing on-prem cloud. I'm able to use those operational tools to understand what's going on, not in my infrastructure, but as well as my PKS container solution as well. And then I get IPAM, right? So IPAM is utilized so I can be able to track and understand what services are being enabled for the security and understanding the dynamic IP allocation of those workloads and Kubernetes components. All right, so again, what does PKS give me? It's an overall solution because if you look at what the networking can do for you, a lot of the network technology today does not give you that multi-tenancy. With PKS out of the box, I get that multi-tenant environment automated for you to be able to go in. Let's take a look at this. So from the command line, I create a namespace, right? Once I hit enter, that namespace foo is actually then deployed with my subnet /24 with my logical switch created automatically as well as my tier 1 services. That tier 1 service is then connected to the tier 0 services, which natting the boundary, which I don't have to even think about. It's automatically deployed for me. The second namespace I create is the bar namespace. Again, I get a different subnet, and when that's created on that logical switch, I then run the command line to create my Kubernetes clusters. And with that said, once I create those clusters, security does automatic. Right when those clusters get turned on, security policies get deployed to those. I'm able to then have an operational aspect of looking into those PKS workloads and understanding what risk and what's secure about them and actually going into the efficiency aspect of deploying without even thinking about it out of the box. Automating at its finest. All right, so again, I talked to you about firewalls. Kubernetes network policies are driven. We can actually tie them to security groups as well, meaning if that workload gets turned on into this development region, I can actually have that security policy applied with that security group. And then also understanding predefined workloads getting deployed up and having those groups created so I can say dev test, production environments, here's the security policies for dev test, and here's the security policies for the production workloads, okay? Lastly, let's talk about option 1, right? So if you look at the predefined labels aspect, so when I turn on these services, I'm able to create those security groups like I just explained to you, maybe in ingress, egress policies, but I can also dictate which microsegmentation is protected to each of those groups. So think about your application environment, right? So my application's up and running, and then I'm able to deploy a whole new cluster of a different multi-tenant environment. So those different dev apps can be running on A cluster, and then on my B cluster, I can have running separately with predefined security policies without even thinking about it. So without even having the manual process of creating security policies, I can create a standard across the board for different clusters. Really sharp. All right, and then lastly, if you go into the Kubernetes network policies, once I get the use case deployed, as you can see, I got a web and DB, so once those applications get turned on for the database or the web database servers, they get automatically applied and then actually labeled within the actual command line side. If you look at the left, you'll see the labels app equals web or app equals database. Those are actually applied for you automatically. Visibility, microsegmentation. So here's the GUI side for the network NSX manager. So inside of NSX manager, I'm able to actually see my different workloads. I'm able to see the dynamic creation of the security groups. I'm actually able to go into and actually predefine those security groups and see the network policies applied to those specific containers. And then like in this use case, it's TCP for the protocol, and then I got my destination port, which is 80. I'm able to visibly see that from a deployment management perspective. And most importantly, I love to show the security aspect of the SDN controller bases. So I can go in, see the different ports applied. I can go in and actually see some topologies on this aspect. So if I look at the trace flow from this container to this container, how it routes through the environment, be able to see those metrics and understand what the network's going on, whether, from the MAC address all the way to the destination and source IP addresses. It's really nice. If you run this command like in like a trace flow, trace route, I'm able to see all the different hops from that container 1 to container 2. All right?
And that's the end of our talk, and we'll be sticking around for a few minutes to take Q&A.
And apologize in the beginning of the PowerPoint presentation for not being displayed correctly. And you know you guys loved our riddle, so I know that was the highlight of the
I
presentation.
apologize about the riddle. Go ahead. Harbor? Sure. What do you want to know? Yep. Yeah, we're leveraging I believe it's called Claire. It's an open source project that enables you to scan the vulnerabilities of that container image. So whatever OS you're putting in that image, we have a series of CVE databases we use. It's not every single one, but it's the major ones. Ubuntu, Red Hat, I gotta look at the other ones. And it'll scan those images for any vulnerabilities it'll find, and it'll flag based on the criticality. Critical, moderate, whatever the severity is. And you can integrate that into your CI/CD pipeline, or you can look through a GUI and see what the vulnerabilities are. It won't address them, but it basically flag that you need to be addressed. And then in terms of pushing, it is integrated into LDAP, so there's role-based access controls to determine what images you get access to based on maybe your LDAP groups or whatever might be in Active Directory, et cetera. Does that make sense? Yes. Yes, so there's a policy you can set to enable, if it's digitally signed, you can deploy it into the Kubernetes cluster. So I would think that would be something you'd automate in your pipeline, right? Once it passes all these, no vulnerabilities, it's signed, bingo, we're good to go.
Are you talking about like the overhead on the actual host itself? Absolutely, there's a lot of performance data that we can actually pass over to you after this. I can definitely get your email and pass you over that performance metrics of what's running on the actual host itself. But depending on your network and your environment, we can definitely talk offline about that and see what you're doing. So coming from the DoD standpoint, I get a lot of customers ask about performance side. If we start looking at their environments, it all depends on what your hosts are, what storage you have in place already. So think about the foundation of vSphere. That's your number one start. If it's healthy and ready to go, and then we can talk about the performance of that as well. But please come up afterwards. I'll give you my business card. Shoot me an email, and I'll be happy to pass over that information to you.
One thing I forgot to mention. There's a session tomorrow called Mission Impossible. Oh, yeah. It's Lieutenant Gunner from the Air Force talking about deploying Cloud Foundry to multiple sites in a year. So that's one we thought we'd pass on, somewhat related.
You know what time that?
I think I want to say after the keynote. I'm not positive.
Okay.
Yes, sir.
Absolutely. Yeah.
Your guess is as good as mine, sir.
It all starts with you. Security starts with you.
They won't be in the AOC.
All right. We'll be up here. Thanks for your time, everyone.